Hi everyone. Today we're going to be talking about a different kind of quadratic application problem. We're specifically going to be talking about maximum and minimum problems. Basically, the title gives it away. If I'm looking for the maximum or the minimum, then the hint is to you that instead of solving, example by factoring or using the quadratic formula, this time we're going to be finding the maximum or the minimum. That means I need the vertex. To find the vertex, I probably need to complete the square. So we're going to go through a couple questions. As I go through the question, I encourage you to pause the video, try the problem, see how it goes for you, and then press play again to see if your solution was correct. So the first problem says that Ricky D hits a golf ball off a tee. Its height above the ground can be approximated by the following equation, where height is in meters above the ground and time is in seconds. First question says, when does the ball hit the ground? So the question you have to ask yourself is, what is the question telling me? If the ball hits the ground, then that's saying that height is equal to 0. Well, if it's telling me that height is 0, then it's telling me to set the equation equal to 0 and to solve for t. So when I set it equal to 0, I'm going to factor, and when I factor, I get out t equals 0 and t equals 6. Well, that means that the ball hits the ground after 6 seconds, and it starts at the ground at 0 seconds, which makes a lot of sense. Part B then says, what is the maximum height of the ball? Well, the first thing you need to ask is, when does that maximum height happen? Well, if I do a little quick sketch of this diagram here, I know that it starts at the ground, and 6 seconds later, it hits the ground. Well, we know that parabolas are symmetrical, so that halfway at 3 seconds is when it hits its maximum height. So if I know time is 3 seconds, I want to figure out what the height is. So basically I want height when I have time set for 3 seconds. So when I substitute in 3 for time, I get out that the maximum height is 36 meters. So this next question is about two boys throwing a football. It says, after 3 seconds, the football is at its highest point, which is 18 meters. It falls to the ground after 6 seconds after it was originally thrown. If the flight of the ball follows a parabolic path, find the equation of the relationship that describes the path of the ball. Draw a diagram to help you. So start with the diagram. So if I draw this diagram, I have a parabola that starts at 0, 0. 6 seconds later, it hits the ground at 6, 0, and I know that its vertex, or its highest point, is here at 3, 18, which happens to be on the axis of symmetry. Well, it says find the equation. I could find the equation in two different ways. I could find it in vertex form and use the vertex and then one of the other 2 points as my point, or I could use factored form and I have 2 points and I have the vertex as my third point. So I'd like you to split your page in half and try it both ways. See if you can figure out the equation in vertex form and in factored form. So hopefully you've had a moment to try solving for vertex form and for factored form. So on the left-hand side of the page, I have vertex form, and on the right side of the page, I have factored form. You'll notice very quickly that A in both cases is minus 2, as it should be. And you'll notice that in vertex form, I have the vertex substituted in, and in factored form, I have the zeros substituted in. So either of these is acceptable. When the question doesn't tell you specifically which type to use, you're allowed to use the most appropriate. In this case, either is acceptable. Okay, so in this question here, it says Taylor has designed a new style of sunglasses. The profit on the sunglasses is determined by the relationship given, where N is the number of sunglasses sold and P is the profit in dollars. What is the maximum profit that Taylor can earn, and how many pairs of sunglasses does he need to make? Well, the first hint in the question is the word maximum right there. And because it's maximum profit and the question here is about profit, I want to find the maximum of this equation, which means that I want to complete the square to get it into vertex form. So everybody try that first. So when I complete the square, I get this lovely parabola. Notice that it opens down, so that means it's a maximum, of course. This here is the maximum profit. Sorry. This here is the maximum profit. So $192 is the maximum profit. When does it happen? So how many pairs of sunglasses does he need to sell? Well, here we know that n minus 13 is equal to 0, so n is equal to 13. So Taylor has to sell 13 pairs of sunglasses to make a maximum profit of $192. Please make sure that because it's a word problem, you write yourself a therefore statement at the end. Okay, this next question talks about a glass workspace that makes lead crystal bowls. And it talks about the daily production in cost of dollars, like in dollars, of this particular thing, where B is the number of bowls made. How many bowls need to be made to minimize now the production cost? And what is the cost when this many bowls are made? So it's asking for this. So again, there's that word minimize. So I know I need the minimum. To get the minimum, I need to complete the square. So complete the square and see how you do. So when you complete the square, you quickly notice that, again, here your cost is $525 and B is 25. So that means that you can make 25 bowls for a cost of $525. Notice again that your A value here is positive, so this parabola opens up. Therefore, again, it is a minimum. So it's really good in the last two questions that you notice what the A value is and that it actually confirms what it is that you're trying to get, a maximum or a minimum. This here is a very common style of quadratics question. It says, a picture measuring 5 centimeters by 10 centimeters is surrounded by a frame. The width of the frame is the same on all sides. That means basically that the frame is an even width all the way around, okay? So it's not lopsided, it's not really heavy on the right side or whatever. The same all the way around. It says that the area of the frame is twice the area of the picture. Find the width of the frame. The width of the frame being how wide that little frame there is. Okay, so let's start by, I luckily have a really nice diagram here, but I'm going to draw one right below it that I can add a little bit more detail to. Okay, so when I redraw my diagram so that I can fit more information on it, I have a length of 10 centimeters of the picture and a width of 5 centimeters. And there's this frame that surrounds it. And this frame is the same distance all the way around, or the same width all the way around. And I'm going to call that width X, because it's the thing I'm trying to find. Now, in doing this, I can quickly see the following. So, I know that the length of the whole frame is 10 plus a little bit of X on the left side and a little bit of X on the right side. So that's 10 plus 2X. And the whole width is 5 plus a little bit of X on the top and a little bit of X on the bottom, which gives me 5 plus 2X. Okay, so reading the question again, it tells you that the area of the picture is 50 centimeters squared. And it says the area of the frame is twice that of the picture. So that means the area of the frame is 100. That means the area of the picture and the frame is 150. So if I put in a relationship of what I know that 10 plus 2x times 5 plus 2x is equal to 150. So basically what I'm saying is that this times this basically gives me this whole area in here. And that makes a lot of sense. So now it's asking you to solve for x, or solve for the width of the frame. So in order to solve, I need to set it equal to 0. and factor. So everybody try that. So if I FOIL out the brackets and bring over the 150 to the other side, I get 4x squared plus 30x minus 100. Find what makes a product of negative 400 and a sum of 30. Or, better still, take out a common factor of 2, and that might make your life a lot easier. So everybody factor. If you're really stuck, use the quadratic formula. So I decided to take out a common factor of 2. I found a product of negative 100 and a sum of 15. I found my two numbers. I divided by the constant, and I got my brackets. Well, this means that x is equal to negative 10, and x is equal to 5 over 2, which is also 2.5. Well, are both answers acceptable? If your answer is no, then which one is not acceptable? Hopefully your answer was no, and you would tell me that a negative frame width is not acceptable. And the answer for the frame width, or the width of the frame, so how thick that frame is 2.5 centimeters. So last question of the day is a little bit more challenging. It says, Alex takes a summer job selling popcorn at the Young Eglinton movie theater, where movie tickets are $15, and about 1,000 people buy tickets each night of the weekend. After doing some market research, he finds that for every increase of 25 cents in the price of a ticket, 50 fewer people come to the movies. And it says what ticket price would result in the maximum revenue. This here is definitely a challenging question. I'm going to let you try this question. I will take it up at the beginning of next class. That's where we're going to start. But in the meantime, I'll start you off with the following. You need to know that revenue is equal to the number of items times the price of those items. If you can start there and give this question a try, I will take it up at the beginning of next class, but I'd like to see if you're up to the challenge. Please make sure that you try the homework questions. If a question is very similar to this question in the homework, don't worry about it. We will be taking it up. But all the others are pretty fair game. I encourage you to draw a diagram should you need to. I also encourage you to put a diagram to scale. So if you're drawing a diagram similar to the one that we did about the football, which was question number 2 today, that might help. That might really, really put into perspective what it is that you're looking at and where the points are on the graph. I'll see you again next time. Take care.